In this lecture, we're going to talk about a cathode rays. In the recent lecture, we have just talked about the formation of the cathode rays and its discovery. So, what are cathode rays? Basically, cathode rays are negatively charged rays which are attracted towards the positively charged waves. Now, there are some identification related to the cathode rays. As you know, a particle consists of a mass and a charge, but here it is a ray. So we have to just identify whether it has a mass or whether it has a charge or not. So what we will do? We will just pass the cathode ray from this field. Now, we know that mass has an magnetic field. As it is written, the mass has a south pole and a north pole. These are the directions of the fields. It has magnetic fields and the charge has the electric field. It has a positively and negatively charged directions, which shows that if a particle is attracted towards a positively charged, it means it's a negatively charged particle. If a particle is attracted towards a negatively charged, it means it's a positively charged particle. So in this way it is identified. Now let's identify whether Cr, which is cathode rays, has mass or not, or charge or not. So in the experiment, when we pass the Cr from the magnetic field, it just go down. It happens due to the gravity. Like if the gravity works on the Cr, that means it has a weight, it has the mass, because mass is attracted because of the weight or because of the gravitational force. So we can say that the Cr has the mass. Now let's identify whether it has the charge or not. It is written in the definition that cathode rays are negatively charged rays. So what will happen if we just pass out the cathode rays from the electric field? First, upper part is positive and the lower part is negative. So it will be attracted towards the upper part. Now what if a Cr, just suppose if the Cr just passes away in the straight line. So we just say that it does not have any charge, it's neutral. And same here, if it passes straightly or goes to the south pole, we just say that it does not have any mass. So as it falls down and it just goes up, so it identifies that these particles, cathode rays, have the mass and the charge. Now the ratio of the mass and the charge is basically the Cr, cathode rays. So we're gonna just write it in this form, E/m, which shows the ratio of the charge to mass. Okay, here in the chemistry, charge is written as the E and m for the mass. So we can say that Cr are beta rays. Now what are beta? Beta. So what are the beta rays? We're gonna just talk about this in detail. First we're gonna talk about the radioactivity. After radioactivity or radioactive decay, some rays are produced which has ability to remove the electron or particles. Now what is the radioactivity? When an atom is unstable, it just tries to remove electron, proton or neutron. That instability just becomes stable when the particles are removed, and that the removation of the particle is known as the radioactivity. So when the radioactivity happens or radioactive decay happens, like when it loses the particles of the nucleus, so we just say that it's a radioactive decay. So when the radioactive decay just happens, some of the rays are emitted from it. These rays are called radioactive. Some of these ionized rays are alpha rays, beta rays, and gamma rays. So first we're gonna talk about the alpha rays, which are the positively charged. So alpha rays are like double positively charged, consists of two protons and two neutrons. Double positively charged is because it has the two proton. So it is double positively charged. It has two neutron. Just suppose two proton, two neutron. What it makes? A helium atom. H2, HEO, atomic number 2. It makes up the helium. And it is also represented as the helium. Like when we gonna just talk about the alpha particles, we can also say the helium particles or helium rays. So the alpha particles are the heaviest because it contains more mass, it contains more charge. So these particles are heaviest particles. Strong ionizing power. Why I am saying it is highly ionized particles or ionized rays? It has a strong ionizing power because it has mass and charge larger or bigger than the beta and the gamma rays. So these are the strong ionizing power. It has a strong ionizing power and less penetration. We're gonna just talk about the penetration later. But just suppose if these rays are just passed through the a paper, it will collide and does not pass. It will just be exposed or it will destroyed. So because of the heavier mass, larger capacity, it cannot pass through any of the paper, foil or any of the other particles. So we can say that it has less penetration, strong ionizing power. Strong ionizing power because it can make more ions. Now let's talk about the beta rays, which I said that are the cathode rays also. The beta rays are negatively charged, negligible mass, like negligible means zero mass. Or we can just consider it the lightest particle. As we just say, electron is the lightest particle, which is also negatively charged. As it is, beta rays are also negatively charged and light in the weight or mass. Negative charge, it has a charge but has no mass. Intermediate penetration, like it can penetrate from some type of the papers, but it cannot penetrate from the highly particles consisting material or papers. It will just collide and destroy it. It has intermediate penetration rate. Moderate ionizing power, it has charge, it can be ionized, but less ionization will happen. That's why they are negatively charged and intermediate penetration will happen. Now let's talk about the gamma rays. Gamma rays are basically just work as like a neutron. That's not actually a neutron, but we can say that as we are expecting a alpha positive charge, as we just take it as a new proton and beta rays as electron. So we're gonna just take up gamma rays as the neutron because it does not have any mass, not have any charge. It has very high penetration. Like if there's no mass, no charge, no collision will happen, no attraction, no repulsion. So like it's the most high, it is a highest penetration rate, and these rays are neutral rays. Electromagnetic waves. Gamma rays are produced from electromagnetic waves after emission of alpha and beta. Like as neutron is made up of proton and electron, as it is, these are also made up of alpha and beta. As I said, no mass, no charge, high penetrating power, weak ionizing power, because no ions, no charge, weak ionizing power, that's the point. Now let's talk about what is penetration, the word I'm using again and again. So let's suppose cathode rays, or we can say that beta rays. Beta rays had moderate penetrating power. Beta rays just passed a foil. Here, some of the rays of the beta particles are attached towards the foil and some just passed away. We can say that it passed. But after that, a foil or a paper consisting more particles will be attracted. Less penetration will be happen because most of the particles will be attracted towards the foil or the paper. Now let's talk about the alpha rays. Alpha rays has mass. Mass is actually a friction. As it is written here also, mass has friction. So due to friction, the gamma rays cannot just pass any of the foil or paper because it has two positively charged particles, so it will just attach to the foil or something else, and it also has a double mass, so it will definitely cannot pass any of the object. Like as gamma rays are the only rays which does not collide with anything and it pass like freely. It pass very easily. So that's the penetration. Penetration is injection to solid. Like we are injecting particles to the solid, so that's called the penetration. Now let's talk about the ionization. What is ionization? Ionization is the characteristics of the particles to become in the charge. Like when a particle just loses an electron, it becomes positive because protons amount will increase and it will become positive. If a atom just loses a proton, it becomes negative. That's how ionization is just held. Now here's the point: ionization is held only in neutral bodies. Why? Because neutral bodies are mostly unstable. To stable the neutral bodies, the ionization happens. That's why this also only happens in the neutral bodies. Charges are made, like when I just talked that if NaCl is NaCl is just break. Na plus Cl. Charges are made. So that's the point. Breakage, molecules are compound. Molecules, compounds like NaCl, H2O, or sodium chloride. Just like these molecules, compounds, these are neutral bodies. So we can say that ionization will help, ionization will help on the molecules, compounds and compare mixtures, just breakage of that. Now let's talk about the heating properties of these cathode or anode rays and the particles. Particles at kinetic energy increases. Suppose a body is standing. It has the potential energy. Potential energy is the stored energy. If we apply force on it, it will move. While moving, it will produce kinetic energy. The potential energy will certainly transfer into kinetic energy. As it is when the particles hit to each other, they also produces kinetic energy. So, when the particles hits, kinetic energy increases, and when the particles hits, it produces the temperature, which is, we can say that temperature is just like the kinetic energy. When kinetic energy is produced, temperature is also produced, or we can identify that if the temperature is increasing, we can say that kinetic energy is also increasing of that body. Second point, particles is equal to momentum plus kinetic energy. A particle has a mass and has a velocity. Like a moving particle has a mass and also it's just covering the displacement. So we can say that it also has the velocity. So mass into velocity is equal to momentum. It also has the energy stored in it, that is kinetic energy. So momentum plus kinetic energy is equal to particles. Let's going to talk about the particles that are used in different actions. Like protons are used in mostly chemical reactions. Have you just listened about the chemical reactions of the compounds, molecules, the chemical bond, covalent bond, ionic bond? These are held on the electrons from the orbitals. So we can say that from the electrons, mostly chemical reactions are held. From the neutron and proton, these are related to the nucleus, so nuclear changes are occurred. And that's all about the today's lecture.